Yeah.
Thank you very much. Hi, it's a pleasure to be here. Thank you for the very kind intro. Today I'm going to give you a bit of a glimpse of my world, what's largely been my world for about 20 years, actually. Basically everything since the pig farm. And I really literally went from farm boy driving tractors to my very first job that paid was actually doing AI research for national defense in Canada. So let's get going. I'm going to talk about AI, and to make it as approachable as I can for you guys, I'm going to give as many applications as I could think of for real estate. Let's get started. First of all, you might ask, what is AI? And basically, if you ask 5 different AI experts, you'll get at least 5 definitions. So I decided I'm just going to give 5 definitions to you guys. So that way there's no controversy. It's kind of throw a rock, you'll get a definition. One of the original definitions came from Alan Turing, more than 50 years ago. And it's the idea that AI, artificial intelligence, is a machine that can replicate human cognitive behavior. And it's best the best example is the test, the Turing test, which is, let's say I'm here, I'm a human, and there's a wall right here, and on this side, there's either a human or a computer. And I can send messages back and forth to this thing on this other side, and I have to guess whether or not it is a human or a machine responding to me. And if it fools me, and I think that it's a human where it's actually a machine, then it passes the Turing test. So that's the idea of a Turing test. It's actually a pretty good measure. And overall, it's assuming that the goal of AI is to replicate human behavior. But that does not need to be the goal. There's a lot of other definitions that are more pragmatic and useful to us today. Another definition, which is pretty cool, is can do tasks that only a human could previously do. Does any of you guys know what this is here? Any guesses? It's more than a bent paperclip. It's actually an antenna. And in the world of antenna design, normally to do antenna design, you have to get an undergraduate degree in electrical engineering, and then maybe a PhD in RF engineering, work for 5 or 10 years, and then maybe, just maybe then, your antenna will be put up in a rocket or used in a cell phone or something. Well, this antenna was designed by an AI, an evolutionary algorithm, evolving sort of survival of the fittest. So it randomly chose 10 basically bent paperclips designs, tried out each with simulation, picked the best, let them have babies, and iterated. And in the end, after 50 or 100 generations, it came up with these designs. Guess what? This design creams every other design out there for what it's trying to do, which is you want to have very good bandwidth, you want to have very good amplification and all that. And this was done by a couple friends at NASA about 10 years ago now, and it went so well that one of those friends started a company basically doing antenna design. So they charge people to do antenna designs. And they don't have to work. They just get the AI to do it. So they're pretty happy. So that's another definition, doing tasks that only a human could previously do. You can go beyond that. Why stop at the level of humans? And my favorite example here is chips. So what this is a picture of a chip that has more than 1 billion transistors. These sorts of chips are designed in about 3 months by a team of about 20 engineers, 1 billion moving parts. How is that possible? AI. So humans guide the top-level process, and they press buttons, and they write specifications of what they want, and the rest of it is taken care of by, so that robot, that is not a robot table, so it did not run away when it saw me. So anyway, sorry for the mess. Basically, these chips are kind of amazing, right? 1 billion transistors designed by a small team, right? And it's possible thanks to AI. And I know this very well because this is where I spent a large part of my career. While I was doing all the creative AI stuff like that, this was the sort of stuff that would pay the bills. And so if you look inside, if you cracked open your cell phone, your smartphone, you would see about 15 chips. And inside that, every single chip was designed in a large part by AI, including by software that I wrote. So it can do basically way higher capacity than what humans have done before. And the most mundane definition of AI, but perhaps the most relevant, is simply a set of algorithms or tools. Basically, the broad set of computer science that is still sufficiently a mystery that has not spawned a new field on its own. Did you know that databases were once considered AI? And spreadsheets? linear programming, all of these things. But once it was sufficiently not a mystery, it got its new label, it became its own field, and then AI is kind of everything left. So these include things like classification, regression, knowledge extraction, and so on. And what I'm going to do now, actually, is walk you through each of these types of tools to give you guys intuition and how these map to the world of PropTech. Once I do that, then I'm going to start to peek into the farther and farther future. How does data relate to AI? And what are the crazy things that are going to happen 5 years, 10 years, 20 years from now? Things like self-owning AIs. Let's get started. So AI, algorithms, and tools. So let's say that someone wants to apply for a mortgage, right? And do you give the mortgage to everyone? What if they have no job, they've never had a job in their life, they have, 10 kids, and they, they've never owned a car, right? Probably not a very good applicant, right? So, but of course, that's someone else who has, 4 PhDs and has worked for their whole life, and their wife works, and everything, then they're probably a good chance that they'll be able to pay. So imagine you have 2 dimensions, salary and age, and from all of your past data, all the people that have paid before, that's the green, and all the people that haven't is the red. What if you could then say, okay, I'm going to come up with a model that will automatically choose, based on the past data, whether or not someone has a good chance of paying their mortgage or not. And that's what this dotted line in the bottom is. That dotted line is a classifier. It classifies, it predicts whether or not someone coming in, some new dot coming in, would be paying their mortgage or not. And it's not perfect, but it's actually a way to do this automatically. That's classification. You can generalize, instead of a binary valued output, you can have a continuous valued output. In this case, we have one input variable, the age of the building, and maybe you're trying to predict the price per square foot, okay? So maybe some new buildings have a relatively high price, and they even get higher after 5 or 10 years. I'm just guessing, I don't know, I'm not a real estate pro. Maybe they get worth a bit more from some data points, and then when they get really old, if they've actually stuck around, then they're probably going to be worth pretty good, a lot more again, because it shows they have good bones, right? But what about in between? What if you want to predict the price per square foot in between? That would be fitting a model, interpolating a model, or the word regression, right? So AI models are really good at regression. In the past, there's things like linear regression and so on, but what if you want to get more and more nonlinear, right? And in this case, we have just 1 dimension, but of course, we can go to 2 dimensions, right? Maybe we want to predict the price per square foot as a function of the age of the building and maybe proximity to the center. Maybe that helps, the city center, right? And then in that case, we have a 2-dimensional regression model, right? And you can go to higher and higher dimensions. You guys are probably all very familiar with Zillow. So Zillow took this idea many years ago now and said, let's predict the price of every single property in the USA and beyond. So this is a picture of Mission Beach, San Diego. I had the good fortune of living here too briefly. And that's the ocean. And that's roughly where I lived, just too briefly, once again. And you look at the prices, and you can see it predicts the price of every single house. So if you're looking to sell, then you get a very good feel, right? Or looking to buy, and you can data mine it in various ways. And at the heart of it, it's using regression. It's this, except many more dimensions, okay? Now, of course, Zillow has actually built a bigger AI team, and something they've done recently is what they call Zillow Home, which is like Google Street Map, but it's for interiors. So you walk around, and you basically get a 3D reconstruction of a home. And it's not just Zillow doing it. I know that one of my panel mates actually is also doing this here, so we can actually bring this to Germany now, which is cool. And basically, it's a way to explore a home without having to explore the home, right? Very useful if you're exploring looking to buy a lot of properties, et cetera, et cetera. This, at the very heart, is regression, because you're trying to reconstruct the 3D model from data points. Imagine instead, what I described before was regression, but it gave a black box model. You didn't see the equations, right? For example, back here, what's the equation that describes that, right? Is it, square footage equals 2 times age of building plus whatever? You don't know, right? It's black box. But what if you could peek inside and get intuition into what that looks like? That's something, that's a form of knowledge extraction, gaining insight into how things relate. So in this case, it's some work that I did in my PhD about 10 years ago. It takes a circuit and it goes through a tool that I called caffeine, basically because I love coffee. And it spits out performance measures as a function of the circuit parameters. So the first one, this is the gain of a circuit. How much does it amplify something? And the gain is, for example, an inverse function of Drain current 1, that's a circuit thing, and it's also a function of these other things. There's some logs, there's some divisions, and so on, right? It actually automatically spits this out, so you can look at it and get insight into what's going on. You know what's cool? You can do the same thing with PropTech. Here's an example. I looked around on the internet, good old internet. I found a couple papers. This is one from a few years ago, which is actually predicting real estate prices of residential single-family homes in Southern California. So basically this here, if you want to understand the average home price in Burbank, it's a function of the mortgage rates, it's a function of the construction age, square footage, and household income, and a few other things. So there you go. It's kind of ugly. These guys actually did a bad job with their AI. You know, this is much better. But it at least gives you guys a feel for what's going on. You can also do sensitivity analysis. You can say which variables are the most important, right? So if I'm looking at a house, if I learn 1 or 2 or 3 parameters, and that's it, which ones are the most important, right? So in this case, they found that age had a 22% impact. The land itself had an 8.8% impact. Number of bedrooms is 6%, and so on and so forth. So this itself is quite useful, too. Let's keep going. Another type of AI is called optimization, and it's basically trying to optimize or something. So you're trying to move around and find the optimal value of x in order to maximize the value of f of x. And so, for example, if you're designing a car, and let's say you want to maximize the top speed, then maybe you can wiggle around the size of the engine to get maximum top speed. And if the engine is too big, then it's too heavy and it can't go very fast at all. And of course, it's too small, then it doesn't go at all. So there's some happy medium, right? Well, you can use this actually in the world of PropTech too. Here's an example, real estate portfolio optimization. You can actually do 2 objectives and basically get a trade-off between expected return and risk, right? So you can do this. This is used all the time in portfolio optimization. Of course, it applies to real estate. You can also do machine creativity. So my friend Greg, he did this thing that automatically synthesized jewelry. And you can see creative jewelry designs. Every single one of these is actually from an AI. Guess what? You can do the same thing for buildings. So this is an example where it's generating various building designs to just kind of see what's going on. Imagine if you're sitting down with architects and they show you this tool. As a real estate developer, you can very, very quickly explore various designs. Or in this case, they're using similar ideas to explore making things more green, in this case for solar building design, right? So these tools are just emerging now, and they're in research in some cases and so on. So I've talked about applications. I'm going to talk briefly about data and the far future. So data. AI really took off a lot in the last 5 or 10 years, and you might ask why. The answer is data. And what that means is the algorithms that are actually really popular now, they've been around since the 50s. The difference is there's way more data. And this chart kind of shows, so the x-axis shows the number of data points, the y-axis shows the accuracy for the same algorithm. And you can see the accuracy goes from 75% all the way to 99% just by adding more data. 1,000x more data pulls your error rate from 25% down to 1%. That is really remarkable because it can take your AI from being useless to incredibly useful and profitable. Google, Facebook, and others realize this, and they realize that the more data that they gather on your emails, your Gmails, on your Facebook, et cetera, means they can make more accurate models to give you ads, which means they make more money, right? So they love this, and they've actually amassed these giant data silos. The core problem, of course, is that there's the siloed data with no economic incentive to share among the rest, right? And probably many of you in the room trying to create PropTech solutions are probably getting frustrated by some of the data silos in the world of real estate. I know in Canada there's some real problems there. So imagine if there was a data marketplace where data could be bought and sold and even maybe given away in some cases, and it's connecting the AI people who could really use the data to build these models and so on with the people with the data connecting to the AI folks, right? That would be pretty cool. Of course, if you had just one marketplace, it might end up as its own silo, right? Imagine, though, you had a way to have many, many marketplaces, not just 1, but 2, 10, 1,000, right? And below that, you had a substrate that pointed to all the data that no one owned or controlled. It was decentralized. It was a public utility, just like electricity, just like the internet. And this is actually what we happen to be building at Ocean. To close off this talk, I'm just going to give you kind of a small pointer to the future. And it might seem crazy at first, but the amazing thing is it's getting built as we speak. First of all, did you know that you can give rights to AIs with laws of today? The answer is, you might ask how, and the answer is, corporations are people too. You can now incorporate a corporation in Malta that has no people attached. It's called a PLE, Programmable Legal Entity. This corporation, of course, can have an AI running it, controlling it, and so on. And then guess what? Boom, you're done. You have an AI that has rights. With that, you can have this self-driving car that also happens to be a Malta-based corporation, so it is self-owning, right? A self-driving, self-owning car. And of course, it works for Uber. It's making a bunch of money. It's very happy. Self-owning roads, right? Charges tolls. It's its own corporation making money. And of course, it can be owned by 10 people or 1,000 people or a million, right? Everyone who wants to use that road. It's just there. Self-owning forests for property management. Pretty amazing, right? If this thing isn't attached to humans, it could stick around for 100 years or 1,000 years, managing itself. And of course, for you guys, self-owning skyscrapers. This here is called the robot building. It's pretty famous in Japan, I guess. And what's amazing, imagine you build a building, and you get that building to be its own corporation, a Malta corporation. Then it decides to pay you back. So effectively, you can manufacture your own customers, for better or for worse. But isn't that kind of cool? This is the first time ever that that was possible. So I'll wrap up with a conclusion. I've talked about sort of the AI of yesterday to the AI of today and the AI of tomorrow. Algorithms, data, all the way to self-owning AIs. For a lot of applications that matter even today, property prediction, street map for interiors, creative building design, real estate data plus, and of course, self-owning buildings. Thank you very much.